The equipment needed in this experiment is a clay triangle, sandpaper or wire roll, crucible tongs, a scale, a beaker, a crucible and its lid, a rod, a Bunsen burner and mat, a tripod, as well as magnesium and matches. So before we even start the actual practical, it's always important to look at the basic chemistry. So if we take magnesium, magnesium has a chemical symbol Mg and the atomic number 12. It's an alkali earth metal, so it's in group 2. It's very reactive because it only needs to lose 2 electrons to have a full valence shell. It's a solid at room temperature, and at very high temperatures it burns with a bright white flame. For the safety of the experiment, the following 3 areas need to be taken into consideration. Firstly, as well as using a Bunsen burner, it is also important to know how flammable the reactants are. Magnesium burns very brightly in high heat, so make sure not to look into the crucible when it's glowing. Secondly, where the product may be gases, ensure that there's a safe distance and avoid inhaling. Also ensure the lab environment is well ventilated. And finally, what safety equipment should be worn. So in this experiment, safety glasses and rubber gloves should be worn. When handling a crucible and the lid, it's always important to use crucible tongs. Even if it's not hot, you should still practice to get used to using them. You make sure to carefully get some grip around the crucible to make sure it doesn't slip. You can practice by putting it on the K triangle and taking it off. When you are picking it up by the lid to let oxygen in, make sure to pick it up by the little handle on top. It always helps to practice to prevent any problems during the actual experiment. With the magnesium, it's important to store it in a plastic bag or in something where air cannot easily reach it. This is because magnesium is very reactive, and so if it reacts with the oxygen in the air, it will create a dull layer on top of the magnesium strip. If there happens to be a dull layer on the magnesium strip, you can just clean it with some wire wool or some sandpaper. However, this can take some time to ensure that it is all shiny. But it's definitely important to ensure that the magnesium can react properly in the actual combustion. After ensuring that the magnesium strip is totally shiny, you can begin to shape it. This can be done by using either a rod or a pencil. So to actually fit into the crucible, you need to make sure that the magnesium strip is made into a coil-like shape. This can be done by wrapping the magnesium strip around your rod over and over very tightly. You'll end up with a snail shell-like shape. Now you should weigh the crucible either with or without its lid to get its mass. You can practice using the tongs to lift it on and off the scale. Now that we've prepared the magnesium, you can put it into the crucible and weigh it for the mass. With these 2 different masses, we can figure out the mass of the magnesium. Now to the fun part. After setting up all the apparatus, you can now turn the flame on. However, make sure to start off with a safety flame. When heating the crucible, you should open the air hole to get the blue flame, and try to get the crucible just above the small blue flame. Make sure to put the lid on top at first, and slowly open it to allow oxygen inside. It's important to let some oxygen in, as it allows for combustion and release of energy. To check to see if the reaction has begun, you can see if the crucible is slowly glowing. As you continue to open the lid to allow oxygen inside, it is important that you do not let any of the product escape. Make sure to have the lab well ventilated to allow lots of air in and out, as you do not want to be breathing in magnesium oxide. Once the ignition has stopped, the reaction is over. Once all the magnesium has combusted, you can observe the physical changes in shape and color. Then put the lid on the crucible and turn the flame off and let the apparatus cool. As magnesium reacts with the air, not only is magnesium oxide produced, but also magnesium nitride. This is called a side reaction. It is unavoidable as most of the air is made up of nitrogen. However, to ensure that your final product is purely magnesium oxide, you can add distilled water. As water is a concentrated source of oxygen, it makes sure that the magnesium nitride converts into magnesium oxide, which also produces some ammonia. You then heat it up to dry the water off. Once the crucible has cooled, carefully using tongs, place the crucible onto the weighing scales to find the mass. By figuring out the mass of the crucible and magnesium oxide, we can now figure out the mass of the product. All you have to do is subtract the initial mass of the crucible and magnesium from the new mass, and in our case it is 0.05 grams of magnesium oxide. However, you need to bear in mind that some may have been lost during the reaction while letting oxygen into the crucible.